Okay, to finish off this unit, we are going to take what we know about quadratic functions and talk about how we can use them to solve certain types of problems. And these problems can basically be referred to as one of two types. And it's related to the words that you guys should already be familiar with quadratic functions. Tell me some properties of quadratic functions. Tell me some properties you're asked to list. Domain, range, vertex, axis of symmetry, y-intercept, maximum or minimum. That's the one. These are called maximum or minimum word problems because if you think about it, there are many situations where if you project something or if you throw something or if you shoot something, Lauren, catch please. Did you see the shape it formed when I threw it? What kind of shape was it? It was an upside down parabola. Okay. That's so anything, and stay calm. So that has physics applications. I knew the response would be like that. Okay, but that's not the only thing. Okay, there are many other situations where things can happen, like when you're working with area, and we're going to see some problems where we can use quadratic functions to solve area problems, business problems. We can use quadratic functions to solve business problems. Okay, because a lot of times, if you think about it, if like when you start a business, give me an object that you want to sell. Socks. So you've decided to start a business where you're selling specialty socks. So what all goes involved in the business? Well, you got to figure out how much it's going to cost to make the socks, right? Like you're going to need equipment. You're going to probably need staff. Okay. And so that means you're going to have to pay out some money for equipment, and it also costs money to operate the machines that print the socks. So make the socks. So depending on how many socks are made, that dictates the cost as well. So there's costs involved. Then what are you going to do with the socks when you manufacture them? What are you going to do with them? Sell them. And so what's the first thing when you've got all these socks and you say, okay, I need to sell them? What's the first thing you're going to say to yourself? How much do I sell them for? Okay, because clearly you paid out a bunch of money, so you want to sell them for a price that's going to make that money you paid out back. Plus, you want a little bit of not revenue, profit. Okay, revenue is the same as the sales you get. Profit is how much money you get from selling the socks, subtract how much it costs you to produce the socks. Right? And believe it or not, there's a point where, depending on the selling price, okay, your profit will go up. Okay, the more socks you sell, your profit will go up. But there will be a point where your socks price will be so high that people will not want to buy them. So your profit will start to come down. Notice the shape I'm drawing. Goes up, reaches a maximum, and then it comes back down. Because if you charge too much, people aren't going to buy. That's just another area where we can do it. So first thing we're going to do is we're going to just look at some quadratic functions. You're going to be given the equation. And these ones are going to have decimals in them now. So we're going to have to use our calculator with this. Okay. So here's an example where It follows a parabolic curve. When you dive, when you jump off the springboard, you reach a certain height, and then you come back down to the water. Something like this. This is a graph. If you jumped off a 3-meter springboard, this would be the time. This would be your height off the ground. Well, you start at 3 meters. That's where your dive starts. It makes no sense to draw the rest of the parabola here. Why? It makes absolutely no sense. Why? Why would you not draw the rest of it here? Because that's what? Like time starts here, right? If you drew in here, this section, you're drawing in negative time. That makes no sense. The parabola has to start when you start the dive. It can't start like you're not on the ground. I mean, obviously you have to climb up to the ladder, but that's not a parabola. Climbing a ladder is not modeled by a parabola. It's modeled by sort of a straight line if you climb at a constant rate. Okay, so really the parabola starts here. So that's a little bit different. We're not sketching entire parabolas here, but they're going to be sections of parabolas. So you start your dive, you're going to reach a certain height, and then you're going to come back down and hit the water, and the graph does continue for a little bit. Why? Because you go under the water, right? But this is, you're not going to draw an arrow here, because if you drew an arrow here, that means that you would fall forever in water, which again, doesn't make sense. So really, we're just taking this section of the parabola to solve this problem. Okay, so here's some questions we can, and so what was done, is we made an equation from this. You guys learned how to make equations of quadratic functions or parabolas when we knew the vertex and we knew a point. You guys had a question like that on your test, where you had to make the equation. So let's assume that somebody came along, made the equation, and this was it. So instead of y, we put h of t, which just stands for height. Okay? So this h of t stands for height. Normally, we would use y or we would use f of x, but we're in a specific problem now, so we're going to use specific letters. Instead of x, we're going to use t, which represents the time in seconds. Okay, so we've got the equation. How would you find the y-intercept of this equation? What would you do? No, you don't need to do that. You're just asked to find, come on, you guys. How do you find the y-intercept? Make x equals 0. We've done so many of those. You guys should know those. Okay, really. But instead of x, we're going to make what equal to 0? So we make t equals 0. So we're going to get h of t equals negative 4.9 times 0 squared plus 6 times 0 plus 3. And what does that work out to? 3. Now we can't, now here, because we're in problem-solving situations now, we don't just stop there. You're asked to interpret the y-intercept. What does it mean in this problem? Well, what does t represent again? Time. And we made time equal to 0. And when we made time equal to 0, height was 3. Explain that to me. Sorry? Okay. At 0, what are the units in this question? Seconds. At 0 seconds, your height was 3, which means in this problem you were, where were you? You were standing on the diving board, or you were just ready to launch. Okay? So at 0 seconds, you were 3 meters above the ground. Okay? So the y-intercept has meaning in problems like these. So especially does the vertex. What form is this equation in? Standard or vertex? Do you see any parentheses? So that means it's not vertex form. It's standard form. So how did we find the vertex when the equation was in standard form? Well, you could complete the square and get the vertex from that. Or the other way, negative b over ta will get you the x vertex or the t vertex. Plug that back in, and that will get you the y vertex or the h vertex in this problem. That might be easier because trying to factor out negative 4.9 and then complete the square from there gets awfully difficult. So this is where that formula really comes in handy. So the x vertex, or really it's the t vertex, is negative b over 2a. So what's the value of b in this equation? 6. So it becomes negative 6. Divide 2 times the value of a, which is, so that's going to give us a decimal answer. So we'll probably want to round to 1 or 2 decimal places. Usually 2 decimal places is good. 0.61. That is correct. And then we take that 0.61 and plug it back into the function to find the y vertex, or in this problem, the h vertex. Okay. So that means we're going to get negative 4.9 times 0.61 squared plus 6 times 0.61 plus 3. So do your order. So you may want to break it up. So for the first part, I'm going to do 0.61 squared, and I'm going to times that by negative 4.9, and I'm going to get about negative 1.82. 6 times 0.61 gives me 3.66, which I'm going to add, and then I add another 3. So when you do all these, negative 1.82, .84? Yeah. So that means the vertex, so we just found it. So if you look at this, we just found this. We know that this is the point 0.61, comma 4.84. Now again, it's not just about finding the vertex. And if you're in AP Stats, you'll know what I mean when I say it's also about interpreting. Okay? What do these values mean? What does the 0.61 mean in this problem? What does 0.61 represent? Time. So this must be 0.61 seconds, right? To do what? Whoa. It takes 0.61 seconds to do what? To get to the maximum. Excellent. So this here, 0.1 seconds to reach the maximum. The y vertex in this problem is height. So what does this represent? In this problem, the maximum height you reach. So 4.84 meters is the maximum height reached. So we can graph these problems like we see in part C. So you start at time is 0, which is the y-intercept. So you're 3 meters on the board. You jump. It takes you a little more than half a second to reach your maximum height before you start coming down towards the water. How would you determine when you hit the water? How would you do that? Can you do it? Do you have to use algebra? Do you have to do calculations, or can you figure it out from the graph? Yeah, isn't it this point here? What time is that about? Like 1.5 would be about here. 1.7? Or sorry, 1.7 seconds, not. So that would be the answer to that. Yeah, that, I mean, you could figure it out algebraically. We just don't quite have those skills yet, because you would have to set x equal to 0 and solve for y, or find the x-intercept. Because really, that's what this is. It's where the shape crosses the x-axis. Finally, what would be the domain and range of this situation? Don't include the time underwater. Okay? Just include the time from the start of the dive until you hit the water. What would be the domain? What's the furthest left point? There's no arrows on this, so it's not going to be negative infinity to positive infinity. 0. Okay? What's the furthest right point before you go underwater? 1.7. So the domain would be about 0 including to 1.7 including. What would the range be? Lowest to highest. Don't include underwater. 0, because here. 4.84. Excellent. Okay. Okay, so that takes care of 2.5. Just give me one